IEEE transactions and 4 papers in IIT Power Electronics and several papers in reputed IEEE international conferences held in India and abroad. He has received awards such as Young Research Fellow from Ministry of IT, Government of India, Young Scientist Award 2017 for Engineering Stream from KSCSTE, Government of Kerala, Outstanding Branch Councillor Award 2018 from IEEE Kerala Section, IEEE PS Chapter Outstanding Engineer Award, etc. He is a senior member of IEEE, the member of ISTE, and Institutions of Engineers. On behalf of Power and Energy Group, NIT Calicut, I invite you, sir, for taking this over to you.
Sir, good morning and welcome, sir.
Yeah. Good morning. Good morning.
Okay, sir.
I think I'm audible.
Yes, sir. Yes, sir.
You please give permission to.
Yeah, okay, sir. I made you, sir. Yes, sir.
So once again, good evening, good morning, all of you. I hope that all of them are very busy Deepavali celebration tomorrow. So wish you all of them are very busy. I would like to cover the lecture on applications of artificial intelligence in distributed generators coupled microgrid system. I have planned two subtitles. One is Introduction to AI and what are the roles of AI, especially in working in power system or maybe in power electronics. So the first half will be general and the next two problems which we addressed in power system with the help of AI. So when you talk about the artificial intelligence, it is applied in most of the engineering and other science branches, especially for more than 30-40 years. So when you talk about human, we are highly intelligent. So when you impart such intelligence into machine, how it will behave? So we are deriving those intelligence artificially so that we expect machines to behave like a human. That's the ultimate objective of AI. So generally speaking, intelligence, there are certain features we have. So just in nutshell, I will just share what are the features we ourselves have. So the first and foremost feature to become intelligence is adaptability to a new environment. So generally speaking, the machines what we use in various applications, they are not intelligent. So why they are not intelligent? Because they are not adaptability, they don't have the feature called adaptability. As a human, we are highly adaptable. There are changes happen in the environment. Sometimes the environment itself completely new, or sometimes it may be totally, there may be a slight change in the environment. So for example, if a children goes to school, so when they are seeing the school, completely environment is new. Maybe going to LKG or maybe the other preliminary level, the school itself is completely new to them. So first time they are seeing teacher, environment, etc., etc. They are new. At the same time, if they are moving from 10th standard to 11th or maybe to college, certain things are maybe familiar to them. So there they are facing change in environment. So, but anyhow, both the cases, they need some adaptability. So according to the environment, the degree of adaptability will change. Degree of adaptability will change. So if you want to create an intelligent system, you should give a feature called adaptability according to the environment condition. So here in our engineering problem, the environment is nothing but input and output. If you take any application, always there are changes in the input and that reflects in the output due to the response of the system. So according to the changes, we should create a system that is called intelligent system, which contains the feature of adaptability. Ability to evaluate. So evaluate is nothing but decision making. Evaluate is nothing but decision making. Suppose if you ask a gathering, which color you like? A general question, which color you like? So most of them will have different answers. Suppose if you ask person one, he or she will say, I like the pink color. Somebody will say blue color. So why all of them are not telling same color? Because they have different experiences. Some of them like maybe blue color. Some of them like. It depends upon the person. It depends upon the individual. So if you give choices, for example, you have A, B, C, D. First one you have infinite answers. Now you are bringing down to 4 choices, either blue color or red, orange or maybe green. Now also all of them will never say a single answer. Why? Because they know how to evaluate. That is nothing but decision making. So if you give choice, according to their experience, they decide which choice they need. So like that, in our engineering domain, most of the problem, they have more than one answer, more than one solution. So we call as a person who deal with mathematics, local minima and global minima. So sometime you may end up in local minima, but we need global minima. So, but we are taking decision. That is the feature, right? So the ability to evaluate and judge, that is a second feature that indicates that decision making. So ability to comprehend complex ideas. Especially here we talk about the data representation. Here we represent data representation, right? So for example, if I ask a question, what is this? I think, shall we make interactive? Deepak, shall we make interactive or only people can communicate?
No, sir. They can communicate through chat box.
Chat box. Okay. So I'm asking a single question. I've drawn a single line here. If we say, what is this? Some of them will say that it is like L. Yeah. Some of them will say it is L. Suppose now I am putting one dot here. Suppose I am putting a dot here. Now, can you guess what is it? Definitely, you will come to the answer that it is nose, right? It's nose of a person. So the idea is little bit complex. Whatever the data which I have represented, I never mean that it is nose or anything, but when I represent the data, the other side you are seeing the picture, you are intelligent, so within one or two guess you are finding the answer that it is the nose. So if you want to create an intelligent system, system should understand the nature of input or output, how it varies with minimal data. That is called the ability to comprehend complex ideas, right? So if you go to some other system, assume that there are 10 inputs they are using to compute the value of y. Suppose if it is an intelligent system with minimal inputs, if the system compute the output, so that is the advantage of their intelligence. So intelligence, the another important feature is the ability to comprehend complex ideas. Then the capacity for original thoughts. So here the problem comes. But so far in the world, many artificial intelligence mechanisms have been developed. There is no evidence so far that there is no original thinking. Only in movies it happened, right? You see some movies like a Terminator or some other movies, that intelligent machine robot started thinking itself. So that thinking is original, right? As a human, we all have original thinking. We all have original thinking. That is called a creativity. That is called a creativity. Suppose if you depute this artificial intelligence to machine, if machine starts think like a human, what will happen? So that is really a dangerous situation. But so far there is no evidence that machine can think by itself. But we can't guarantee, right? We can't guarantee. Anything may happen with the machine. So the ability to learn quickly and learn from experiences, this decides the degree of intelligence. This decides degree of intelligence. Some expert system may be very fast in nature. Some expert system may be slow in nature. It depends upon the problem. It depends upon the method which we are trying to use. As a human, if you investigate each and every one of us, we have different learning speed. Maybe with respect to different art. Some of them may be good in cricket. There they may be fast learners. Whereas in studies, they may be slow learners. Right? There are some cricketers, right? Good in cricket, but not good in studies. So like that, according to our interest, the learning speed will vary. So, as I said, this decides the ability to learn quickly. Ability to learn quickly. So that decides the degree of intelligence. And finally, ability to comprehend the relationship. That's as a human, we do how to comprehend the relationship. But the first four features which I have highlighted, adaptability, decision making, comprehend complex ideas, and quick learning. These are the most important features of any intelligent system which we try to create artificially. So when we try to, why do we go for AI? It has different different usefulness. So especially in engineering, you take any system, the powerful tool which we use even today is mathematics. Especially in engineering, mathematics is really a backbone. Especially in electrical engineering, each and every system is developed with its own fundamental principle and the set of equations. But even then, we are facing some problem. Why? If you try to write maybe Ohm's law, There we write V is equal to I into R when temperature remaining constant, right? I think as an electrical engineer, we write Ohm's law as V is equal to I into R when T is constant. So in my opinion, is the temperature remaining constant? Never. You go to any practical system, start from zero speed. Case a motor, you take a case of a motor, you start from zero speed and accelerate the speed. What will happen to the temperature? Increases. You take any system, in electrical system especially, temperature will never be constant. But Ohm's law states that V is directly proportional to I only when temperature is constant. So is it practically true? No. Is it practically true? No. So this is the biggest problem in mathematics. Mathematics are valid only when some conditions are satisfied or some initial conditions, assumptions, approximations. So you take any mathematical equation, definitely there are some approximations and some assumptions we are bringing into the modeling. So in my opinion, what is the necessity of those assumptions? Is it practically correct? No. So if it is not practically correct, and whatever the solution you find from those mathematics, how it will be true then? Definitely no. There are some accuracies. We always permit some upper limit and lower limit, and then we play between that. But whereas in artificial intelligence, the non-linearity of a system can be represented as such. So if you have a system like this, you all know what is a system. Set of components arranged in a sequential manner to achieve certain task. So here, when you see a system, you have set of inputs and set of outputs. And if you try to take a nonlinear system, this represents a nonlinear system. Whereas in artificial intelligence, the nonlinear system taken as such to analyze or maybe to do further process. But whereas in mathematics, we either convert nonlinear system into piecewise linear, and then we do the forthcoming steps. So that may end up with some answer which may not be feasible in practice, sometimes very critical applications. So we have to take the system as such. So there is a way in AI, artificial intelligence. Then input-output mapping. So when we talk about these mathematics, we should know each and everything about the system. So for example, if you take about a circuit, when there is a current flow through the circuit of an RL, you take a simple RL circuit, you write Kirchhoff voltage law, and then try to solve the equation, you should know each and everything about the system. Though you are going to talk about the voltage and the current, irrespective of these two, you should know each and everything about the system. But whereas this AI, artificial intelligence, never bother about the system. It only bother about input and output. Input and output. So we do not know what is inside. We never bother what is here. It's like a black box. It is like a black box. So in the case of AI, we only bother about this input and the output. So with the help of these two, we can do whatever we wish, maybe modeling or maybe control or whatever we want. So that is possible in AI. Without the proper mathematical equations and other things, we can go ahead with input and output mapping. That is the second usefulness of AI. So I already told you adaptability. So whenever you talk about system itself will never be adapted. System itself will never be adapted. System in the sense the parameters. System is what we represent that parameters as A, B, C, etc. So whereas in intelligent system, what we say, the system parameters also can be adapted according to the change in input and output. So that is a major usefulness of our AI. That is nothing but adaptability. Evidential response. You all know that each and everything happen in the world with some evidence. As an engineer or maybe scientist, they are tracing out some reason, that's it. They are tracing out the causes. So that is the beauty of AI. If you try to give this AI, artificial intelligence, to a machine, so that you can naturally create some evidence when there are faults, especially fault diagnostics, right? Fault diagnostics and fault tolerance. That really will be very good in the presence of artificial intelligence rather going to the conventional mechanisms. Because as a human, you all know that we have evidence for each and everything. You all are today in this class. Why? Because there is an evidence, right? So without evidence, as a human, we never do it. Each and everything have some evidence. So if you try to give or empower this AI into a system, definitely the system can produce some evidence. So that evidence that can be used maybe to post fault analysis or maybe some diagnostic process. I told fault tolerance. When you try to see most of the system, when it fails, the system will never fail 100%. You take any system, due to some minor portion, less than 10% of the whole system, the system fails. I think most of you may agree with me. You take any system, right? If you take a satellite launch, when there is a failure in satellite launch, 100% it never fail you, right? That's what recently that when that satellite was failed to land in our moon, they said that it is not a failure, it is a success. Why? It is, we know how it reached the moon surface, still that it is succeeded, right? We can't say everything failed. So you take any system, it will never be failed 100%. So only some percentage failure may cause the whole system to fail. So what I want to convey here, artificial intelligence system can function even though there are minor faults. That is called fault ride-through or fault tolerance. Whereas a mechanism like a machine, if even there is a small fault, you can't ride it, right? Because it is not intelligence. So whereas in AI, definitely it can have fault tolerance as the main usefulness. So when you try to see the artificial intelligence techniques, what are all the way we realize this AI in engineering? So far we have seen usefulness. Now we are moving to the maybe a realization of AI in various applications, right? Different applications. In power system, most of the time we use AI as a system modeling. For example, industrial load model. So if you want to model the total industry, you can use ANN. So that is where the ANN is going to model the entire system. So with the help of these data, that is input and output, you are going to create a model based on this AI. This AI receives all the inputs and it produces those outputs. However, the real system behaves in the similar manner AI behaves. Suppose if you try to make this system with the help of mathematics. For example, if you take a DC-DC converter and develop mathematical model, you all know how much difficult it is. And moreover, we are taking lot of approximations. A simple DC-DC converter, if you take, for example, you take a boost converter. In the case of a boost converter, when duty ratio varies, if this is your output, output voltage varies like this, right? But practically speaking, it will never vary like this. So it starts from here, gradually it comes down, then it increases, then it reaches zero here. Why? Because of the parasitic element. But ideally, we may take that resistance of the inductor neglected, capacitor resistance neglected, everything we neglect. We take ideal circuit, and if you do the analysis ideally, it looks like this. But whereas practically speaking, the system behave like this. But even if you do experiment, you will never get exactly same. Why? Because practically there are some other effects, and those effects we are neglecting. So these are the major difficulties whenever you deal with a system, and that too you all know how tough to deal with system which has the order greater than 2, third order, fourth order, fifth order, like that. So we developed recently a converter which is having the order of 7. You can imagine how tough to deal the 7th order system. How tough to deal 7th order system. So mathematics, we are absolutely comfortable in 2nd order, of course. If order increases, we all know how tough to deal it. How tough to deal it. But whereas in AI, we least bother about the order. We only bother about what is your input, what is your output. That's it. So whatever the system behave, exactly in the similar fashion, we can model the system exactly. That is the main advantage or application of this AI in engineering. If you try to see literature study on AI, more than 40% papers belongs to modeling problem. They are using different AI techniques like fuzzy logic, artificial neural network, etc. to model a system. Because I already told you what are the difficulties of mathematics. So we need intelligence. So they are using intelligent tool to make model of the system. So there are two types of system, you all know. One is called static system and dynamic system. So you can model both static and dynamic with the help of AI. According to the applications, you can prefer a suitable AI technique to realize your static system or dynamic system. Both can be modeled in AI. Yeah, that too in renewable application, especially when you try to use renewable sources like solar PV, wind, etc. Modeling is very crucial, and that too when you take the solar PV equivalent circuit, this is a single diode model. Even sometime you may not get exactly correct output in the upper and the lower boundary. So if you take the characteristics of solar PV like this, so even if you take a model, it is very tough to derive the model in the upper boundary and the lower boundary. I am telling this region. You can use either the double diode model or whatever may be the mathematical model. You can't exactly get the behavior, especially in this least boundary and the most boundary. Because these mathematics, there are assumptions and approximations involved. And that too, the system will be more complex in the presence of partial shading. I think all of you might have know about what is called partial shading. So when you try to do modeling of solar PV in the presence of partial shading, it is really very tough, very challenging. You can't imitate the exact partial shading characteristics with the help of mathematics. So you can go ahead with some AI tool. So that definitely will help you to realize such a partial shading system in more realistic manner rather than this mathematics. So parameter estimation and another main application of AI is parameter estimation. And especially in power system or machines, we are often using this tool to extract the characteristics of a particular system. That is called the parameter estimation. So with the help of the characteristics, again in this example, if you see output power versus efficiency, we are drawing the plot. Once if you know these characteristics, from these characteristics, you can estimate any parameter of the machine. But whereas mathematics, it is not possible. Certain extent, if you know some mathematical relations, you can extract some data, but not all. So that, especially in parameter estimation problem, AI is really a good tool to estimate certain unknown parameters which are maybe essential, like a conditional monitoring system, or maybe a design based problem. Various problem we try to use this AI tool, especially for parameter estimation. As I said already, if you take a DC-DC converter, if you try to design L, C, other parameters, and whatever you get through mathematics, finally what we do, approximation. So maybe multiplied by 1.2 times or 1.5 times, then we go for real-time realization. But whereas in AI, some extent, with respect to the performance of the system, you can extract the parameters or estimate the parameters based on the response of the system. That is the unique feature of applying AI in especially parameter estimation problem. Performance prediction, especially applications like load prediction. You know, load prediction is one of the major problem in power system. So load prediction, load modeling, I already told load modeling, load prediction or load forecasting. Load forecasting is one of the major challenge in power system. So people are using AI in load forecasting problem. Similarly, weather prediction, weather forecasting, rainfall forecasting, like that there are different parameter or performance prediction problem. You can go ahead with AI. And control application, this is main application of AI. Most of the I already told you, modeling, there are 40 papers are coming out, 40% papers are coming out. Control approach, even you go to transactions like industrial electronics or maybe power electronics or maybe power system, definitely you can see minimum 1 or 2 papers in every issue on the control problem. So though we are good in power electronics or in power system, we may not be that much sound in control, because we may neglect that we are not from control. But if you are not good in control, how can we make efficient control system? Because each and every system today in power electronics or maybe in power system, we have to control it properly. But when you try to see the control problem, the controllers like PI or the family of PID are popularly used. Here there is a constraint. PI controllers are mathematical controllers. We are exclusively linear controllers. So how linear controllers can effectively control a non-linear plant? That is the biggest question mark. So in control application, definitely this AI can help. So there are different AI techniques. I will try to show some of the applications like genetic algorithm and particle sum optimization. If time permits, I will show fuzzy logic application in power system. So with this, I am concluding the first half and I am moving to the second half. If you have any doubt, please put it in the chat box and later we will address. So you all know that this is the structure of the power system, like generation, transmission, distribution and utilization. And this power system was moved from DC to AC in the year 1887. So in fact, Thomas Alva Edison started the power plant in terms of DC in the year 1882. after the concept invented by Nicholas Tesla, supported by George Westinghouse, the total power system become alternating current system, like generation, transmission, distribution, utilization, everything was AC. It was rolling the entire power system maybe till the end of 20th century. Now we are in 21st century. You can't find any power system with AC alone. It's a mixture of AC and DC throughout the system. In fact, a few years back, the generation was only AC. But after invention of solar photovoltaic, that to grid connected system, it also become DC. So generation also available nowadays with the DC. Now you all know transmission. Already people go for HVDC. DC system, then loads. There are many loads which are DC in nature. Best example, LED lamp. So the whole power system is revamped today, but it faces plenty of challenges. So few challenges I will list here. So reactive power management. You all know that reactive power management is one of the biggest challenge because reactive power varies in the system dynamically. So according to that, we are in the position to control this reactive power. And that too after integration of renewable energy sources, the challenge become, the complexity become very high. All right. So this that is a depth topic. So I am not going into that in depth. Just the outer periphery I am touching. So reactive power management is really one of the biggest challenge after the integration of renewable energy sources. So when you talk about the variation of real and reactive power, the two parameters are affected. One is voltage and frequency in the AC system, and how to regulate voltage and frequency, that is very big challenge. So in fact, after integration of renewable energy sources, real power and reactive power demand continuously varies, not like the conventional system. So in that situation, that too the renewable energy sources like solar PV, wind, which are highly intermittent in nature, so that it is very tough to have the control of real power and the reactive power. So when you talk about the conventional power system, the conventional power system is filled with classical alternators, which is having rotation, that is nothing but huge inertia. So naturally, the overall stability of the system very high. But nowadays, after the integration of renewable energy sources, the stability become a big question mark. So because the sources like solar PV, fuel cell does not have any rotating part. So there is no mechanical inertia. So the stability become a very threatening factor in the presence of all the renewable energy sources. So entire world focus on the renewable energy sources. I hope in 2020, 20% they said, I do not know maximum we reached or not. Maybe as soon we will know. But 2030, 2040, 2050, definitely we will see a drastic change in the whole power system, especially from renewable energy sources. The whole power system definitely will be dominated by renewable energy penetration in the near future. But what is going to happen, the total system, that is really a big question mark. So there is no other way. Entire world is focusing on renewable energy sources. We are in the position to move from conventional to non-conventional. So when you talk about the synchronization issue like load dispatching, then maximum power extraction from renewable energy sources, these three are definitely big issue, right? Synchronization, load dispatching, maximum power extraction, all of them are one to other tightly connected, so that it is highly sensitive in the present situation. So that may lead a burnout or sometime maybe a blackout, and that highly affects the term called reliability. So the another term, power quality, is also joined with the renewable energy sources. So far, maybe before renewable energy sources, we restrict only the power quality of load, that is load harmonics. But now we are in the position to restrict the source harmonics also. Because when you talk about the sources like solar PV, That is also integrated through power electronic system. So harmonics are unavoidable when you integrate sources also. So apart from load, we are highly focusing on power quality in the source side also. So these are the few challenges which I have listed. So you all know that there are different distributed generators which are already coming to the consumer end, like solar PV already being used for past 10 years. Wind energy system, there are a lot of induction generator based windmills are already deputed in most of the states to generate electricity in terms of 200 kilowatt to few megawatts, and maybe micro turbine based hydel system. Biomass, in fact, good technology, but even now the technology is not matured enough, especially in the commercialization. So hope that it will be revamped and it will come with an attractive color in the near future. So fuel cell is also one of the good technology, but still a lot of research work is going on in the fuel cell to improve the performance. It is not yet commercialized much. I hope that whatever the hurdle we faced in solar PV in the initial stage, it was completely removed in the later stage. In fact, in solar PV, we are in third generation now. Like that, fuel cell also will come up drastically in the near future. We are waiting for that. Apart from that, the storages like battery, ultra capacitor, those things are even flywheel. Even flywheel also commercialized in countries like Germany. Some of the European countries, they have started using fuel cell, that flywheel of 5 kilowatt hour like capacity in their residential system. So what I want to convey from here, already the non-conventional energy sources like solar PV, wind, battery, fuel cell, etc. already arrived at the consumer end. So when all the system arrived at the consumer end, the whole system is looking like a source with power electronics. So now if you distinguish power electronics and power system, in fact, you will fail. You can't distinguish power electronics and power system. Both of them are highly tighted, right? Source side, you can take anywhere in the power system. Generation, I said solar PV with inverter, power electronics. Transmission, HVDC, power electronics. In fact, distribution, we are currently having a transformer that are also going to be solid state transformer in the near future. They are also power electronics. And loads already become power electronics. And if you see the whole power system full of power electronics, right? Generation, transmission, distribution, utilization, everywhere power electronics. In fact, only thing is same. Only one thing never changed in power system so far. That is that wire, that conductor which carries power. No, that alone never changes still. But who guarantee? After some time, wireless power transmission will come. That wireless power transmission is full of power electronics. Now, what I want to conclude from here, the power system is full of power electronics, right? Our system is full of power electronics. If you see power electronics, what is this power electronics? There are set of active elements like diode or maybe MOSFET, IGBT, all these things we are using maybe to achieve certain signal conditioning, right? MOSFETs and IGBTs we are using along with the passive components like inductors and capacitors. We are trying to achieve certain small signal conditioning, like AC to AC, like AC to DC, DC to DC, like that. There are different level of conversion we are doing in terms of voltage and current. So according to the application, we decide what type of conversion we need. So the whole power system is full of power electronics. So when you try to see the distribution system in the near future, it will be look like this. How? Renewable energy sources like solar PV, wind, your fuel cell, all these things will be connected through power electronics. And you will have a DC microgrid. In fact, you will have two different DC microgrids. Recently, I have read a paper published by, I think, the authors written by Professor Padev from IIT Roorkee. He made a microgrid system with two different voltage and integration of that two different microgrid system with the help of this like an isolated converter. I have seen a paper written by Professor Padev from IIT Roorkee. So recently, one more paper I have seen in industrial electronics by Professor Suryavanshi from NIT Nagpur. He also proposed some power electronic topology to integrate two different DC systems, one with the 370 volt, another one with the 700 and some volt. So what I am conveying here, power electronics only going to be the future. Power electronics is our real future, right? Without power electronics, you can't run our power system. So already I told you the conventional, the classical thinking of power system itself completely abolished. If you see the problem like a unit commitment, economic dispatch, it will never be anywhere, maybe after some time, right? In fact, today we may use some extent, but I challenge you, maybe after some time, like 20 years, 30 years, unit commitment or load dispatching, economic load dispatching will never be there in the presence of renewable energy sources, I am telling. So the total grid structure looks like this, full of power electronics. So the transformer, that also will be power electronics. And here you have your AC system. So like that, when the distributed generators are bringing into the distribution system, without power electronics, you can't do anything. So when you try to see the whole system, it will look like a microgrid. So microgrids with full of power electronics. So for the past 10 years, changes are happening very drastically. Already the solar PV, battery, these two already reached consumers. The wind turbines already reached industries. And we are waiting for one more very big guy, that is nothing but electric vehicle. And when EV also getting integrated with this grid, so the show will be very tough to manage, right? Because when you see electric vehicle, the power consumption is totally different from the conventional system. So if you take the commercially available, recently launched vehicle from Tata, they said that the capacity of the motor is approximately 95 kilowatt. And the capacity of the battery is 30 kilowatt hour. So that too, you have to charge in 30 minutes. Can you imagine what is the amount of current this 30 kilowatt hour battery is going to take from the system? It will be several hundred amperes. It will be several hundred amperes. If you work out, you can get the exact value, several hundred amperes. As a power system engineer, you may know how tough the situation will be. That too after bringing electric vehicle, which will be the near future, right? Already government of India started a lot of initiatives to promote electric vehicle. I think in another 4 or 5 years, entire electrical vehicle will be launched. And by the time, what will happen to our system? Very tough. The whole microgrid is going to struggle unless otherwise, if you are not finding a feasible solution. So what I want to convey from here, we have done some work at NIT Calicut on the stability improvement of microgrid using the concept called virtual synchronous machine. So the concept is something like this. You all know that when the circuit breaker is closed, the whole system will be grid connected system. When the circuit breaker is opened, it will become an autonomous system. So in fact, in the autonomous system, in the grid connected system, whatever the grid frequency you have, it will be same. And whatever the voltage you have at the point of common coupling, it will be same. Because grid voltage, grid frequency will be the responsible for the local the system. So the total microgrid will work depends on grid frequency and grid voltage. And that too, the intermittent nature of sources like solar PV, battery, when it draws power and if it is pumped the power into system, there are transients. There are transients. So in fact, all the rotation system, each and everything coming into the grid system only in the generation side. In fact, this is a distribution system which is called a weak distribution system. You all know that it is very, very weak. So this is a very weak distribution system, right? So you all know that it is a very weak distribution system. So very tough to handle, right? So when you talk about such a weak system, how effectively you can manage the renewable energy sources such as solar PV, battery, etc. Right? Because there is no rotational system here, so stability of the whole system will be a big question mark. The stability will be a big question mark. So that too, the situation will be very worst when the circuit breaker is open. And that too, when the solar PV system operated at MPPT, this MPPT will try to pump maximum power into the system. So assume that there are lesser number of loads. What will happen to the system? The whole system will collapse. Now you may realize how tough the stability will be. So we have done some studies here on a virtual synchronous machine, which is going to act as a third agent to improve the stability of the system. So when you see what is this virtual synchronous machine, it is not a real synchronous machine. A battery with inverter and a control strategy, together it is called as a virtual synchronous machine. A battery, storage device, and a power electronics, that is nothing but inverter, and there is a control strategy. These three are together called as virtual synchronous machine. The characteristics, in fact, the unique feature of the synchronous machine is this equation. So that is nothing but J into d omega by dt is equal to Tm minus Te. In fact, here it will be called as Pm minus P because it is a d omega by dt. You can put something like inertial constant h here, so it will be comfortable to understand. So I am, instead of moment of inertia J, I am putting h. Okay. So if you multiply both the side by W, you will get here power. So h into d omega by dt is equal to Pm minus Pe. So this h is a constant. So this equation is the unique feature of your synchronous machine. What it is? So this term will decide the operating speed of your synchronous machine. If this is positive, accelerated. If it is negative, deaccelerated. So that feature we are going to impart into the virtual synchronous machine through these control mechanisms. The battery, inverter, and the control mechanisms all together called as virtual synchronous machine. So you may look into our publications so that you can get more detail on how the virtual synchronous machine behaves like a conventional synchronous machine. So this is an inertial constant and this is Tm minus Te. This is the conventional system, and this is something like a new term which we have added here to regulate the frequency like AGC, automatic generation control. And this is your damping. This is your damping mechanism, right? So this is something like term which mitigates the oscillation present in the system. Means in the oscillations present in the frequency of the synchronous machine and the grid system. However, the damper windings behave the similar way. We have added term called damping term, and this is like a drooping. You all know what is called a drooping coefficient, right? Like a drooping mechanism that is used in the AGC, automatic generation control. And with respect to the whole equation, we are going to control the speed of the machine. So that is the unique feature of the control strategy, which is coming under virtual synchronous machine. So we have implemented the virtual synchronous machine like this. We have taken a DC source and there is an inverter, three-phase inverter, followed by LC filter. Sometime the system goes to autonomous mode when the circuit is open. It will be disconnected from the grid and it will meet the local load. By considering the autonomous operation, we have taken LC filter. We have taken an LC filter. If your system is a grid-connected system, you can go ahead with the L filter. In fact, in this virtual synchronous machine, we have provided a feature to operate in the remote mode, that is nothing but the islanded mode. So we have preferred LC filter. So this is the control part of the whole virtual synchronous machine, so that according to the voltage and current sensed from the point of common coupling, in fact here we take and here we grid the voltage we sense. According to that, the conventional mechanism work. But whereas in the virtual synchronous machine, three sensors are sufficient. That is another attractional feature of VSM. So with the help of three current signals, the whole VSM can be operated. So by considering time, I am not going to anything in detail. I will just show what performance improvement we have done here with the help of AI. So you all know that as I have shown in the swing equation, two parameters are from mechanical. One is the angular speed, that is nothing but the rotating speed of the machine, and another one is the torque. So according to the variation of the speed, the term voltage will vary. According to the maybe the torque term, the current varies. So these two are highly correlated, or maybe something like interconnected. In the case of the real synchronous machine, you all know that by adjusting the power angle, we vary the real power. In fact, variation of real power will be reflected in reactive power also. Similarly, you all know how to adjust the magnitude of the voltage. So by adjusting the magnitude of the voltage and the power angle, we achieve the real power and the reactive power control. The similar mechanism we are following in the virtual synchronous machine also. So we are adjusting both del and Vm. So this is the magnitude of the voltage. That is nothing but the modulation voltage. In the case of inverter, you all know what is called the modulation voltage. So that modulation voltage we are controlling Vm and del, so that the term real power and the reactive power will be controlled. So as I told you, we intend to control only real power by controlling angle. By default, Q also will change slightly. So we need some decoupling mechanisms, right? So there are different control strategies available to control real power and the reactive power, like a Phasor control, vector control, different mechanism people are using. So comparing to the Phasor control, the vector controls are most popular. So in fact, in our work also, we have used vector control. Vector control means all the ABC coordinates we will convert into DQ coordinates. So after converting into DQ coordinates, we dedicatedly control this ID and the IQ. The variation of ID reflects in terms of real power. Variation of IQ reflects in terms of reactive power. So here I will show the results what we got from the simulation environment. So when you keep your torque and speed at the rated value, the system injects its real power and the reactive power with respect to the reference. So in fact, here we have given the reference of ID as finite, IQ as 0. so that it injects only the active power, the reactive power becomes zero. So here you can see that the voltage and the current of a particular phase are in phase. So you can see R, Y, B, all the currents are in phase because we are only controlling the real power, the reactive power remaining zero. So the main beauty of virtual synchronous machine, you can make the machine to control in any quadrant. Quadrant in the sense, it is real power and the reactive power. So if you want to inject real power and the reactive power into the grid, yes, it is possible. I told that there is a DC source. So the reactive demand of the AC side will be met from the DC side. So first quadrant. Here also you can operate. You can inject real power, at the same time you can consume reactive power. Here you are absorbing the real power but injecting the reactive power. Right? That always we require whenever we charge the battery. You all know that. Whenever we charge the battery, we consume real power and we have to provide the reactive power support. And that is also possible by VSM. And fourth quadrant, we can inject and absorb or maybe absorb both real and reactive power here. So VSM is such a unique mechanism, you can operate the whole system in anywhere in the quadrant. So here in fact, I have shown that at 0.2 second we are changing the real power reference so that the electromagnetic torque slightly varies so that the active power is maintained at the reference value. Okay. So you don't think that it is exactly same. There is a slight change in the magnitude so that you can see, you can observe from the current. The value of current slightly changes here from this magnitude to this magnitude. So what we have done here, especially in terms of artificial intelligence, we have used a genetic algorithm mechanism to tune the PI controller. You all know that. I told you there is a ID reference and there is a ID actual. So this is an ID star and the IQ star, and there is a PI controller. Similarly, there is an IQ reference, and there is this will be plus, and I think this is plus, and this is minus, and this is minus, and this is plus, and this is IQ star. So when you talk about this, there is a PI controller here. And when you take the value of PI from the small signal model of the whole system, in fact, we have developed the small signal model of the whole virtual synchronous machine, and then we have tuned using Siger-Nicholas method. Even then, we found significant oscillations here. In terms of real power and the reactive power. So here, in fact, we have used a genetic algorithm approach to tune the value of PI. So here you can see we have taken the error as an objective function to be minimized. So the fitness value comes down because the problem is a minimization problem. And we have taken the population size as 100. You can see the population size as 100. And you can see the fitness of each and the value of the initial population, and almost at the 20th generation, almost the optimization is converged, and then we permitted maximum of 50 generations, and you can see that at the 50th generation, the fitness value more or less same to all the populations. So there we stopped the iteration, and we have shown the result. In fact, I could not show the comparison result here. I think that work is still under review with some other work we have done recently that is still under review in a transaction. So what I want to convey here, we found genetic algorithm is one of such an effective tool to tune a complex PA controller which involve in a complex system. You all know that I think the order of the system is something like a 7x7, and when we try to define when you try to find the PI constants using Synchronous method, though we set the values race time, steady state error, ESS, and the peak overshoot, each and everything we have set and we tune in a particular condition. So, for example, assume that your rated power is 1000 kilowatt or 1000 watt. Okay, for 1000 watt, we are tuning the value of Kp and Ki by taking the condition TR, ESS, and MP. But the system gives poor response when there is a step change in maybe from 100 watt to maybe 100 watt to 500 watt. If you investigate why your tuned PI controller gives such a poor response, because you have tuned for 1000 watt. Then you may ask a question, sir, why don't you change the condition and you can retune it? You can do it. Suppose assume that you are tuning at 200 watt, definitely the PA controller will give poor response in 1000 watt. Kp, Ki value using the conventional method is very tough. So there the AI plays a major role. The AI plays a major role. So we have extracted the features of one of the AI technique called the genetic algorithm in our application, and we have come out with a good result. And in fact, hardware also we have seen that the performances are really satisfactory comparing to the conventional system. So as I already pointed out, we are dumping the power into the AC side, and similarly we are drawing the power into DC side by providing the phase shift of 180 here and in phase here. So by considering time, I am not going to explain this in detail. We have done another work. We have done another work on the application of particle sum optimization, especially in the optimal location of battery charging station in the microgrid environment. So this work was in fact done by one of my power system student called Kushbu Gupta with one of my PhD student called Ravi Shankar. So this work is really interesting. When you talk about I already shown a microgrid structure. In the near future, all the electric vehicle, they are going to integrate it with the distribution system, and already solar PV, UPS battery, all of them have arrived at the consumer end. So if you try to imagine a distribution system with full of renewable energy sources and the conventional utility grid, what is the impact of charging of electric vehicle on the whole system losses? That was the investigation, in fact, we have made in this research paper. So you can download this paper and you can have the elaborative study. So the algorithm works like this. We are reading all the conditions of the distribution system, and finally we are running a particle sum optimization. We are running the particle sum optimization so that the particle sum optimization find the location where the losses are minimum. As you all know that it is highly a dynamic system. The distribution system is highly a dynamic system. Load also varies, source also varies. The charging condition of the battery also varies, so that which will be your optimal point to connect your electric vehicle to charge with minimum losses. So that is the objective of this thesis. So, in fact, the particle swarm optimization flowchart is given here, and we are trying to find the global position of the particle. That global position is reflected in terms of the optimal location of the charging station in our work. So this is the system which we have considered under study. A small distribution system we have taken along with the conventional utility grid, and there are renewable energy sources we have connected like this. And in fact, we have taken 2 charging stations. So charging station 1 and charging station 2, and there are 9 buses you are located, 10 buses in fact, including this there are 10 buses. So where this charging station can be located? Where the charging station can be located, so that the overall distribution losses will be minimum. That is the research attempt we have made, and our particle swarm optimization find an optimal location as the picture which we have shown, 3 and 10. So 3 and 10 are the optimal locations, so that the battery of the electric vehicle can be charged with minimum losses of 1110, it approximately 1.1 kilowatt, whereas conventionally 7.9 kilowatt is the losses. So that is the main advantage of the artificial intelligence which we extract in this work. So extremely I am very sorry, because I have a third work which is based on the fuzzy logic, and that work what we have done, improving the dynamic feature of the virtual synchronous machine using fuzzy logic. That was the research attempts we have made. That was very much interested, especially in the dynamic behavior. Our designed system worked very effectively, but by considering time, I am not going to that in depth, so that I am coming to the end of the lecture now. So thank you all of you for your patient listening. If you have any question based on the lecture which I have conveyed in the past 1 hour 20 minutes, you can ask some doubt. As I pointed out, I have completed in fact 3 title in today lecture. First part focused on artificial intelligence and its features, as also the applications. So in the usefulness, we have seen non-linear characteristics, adaptability, input-output mapping, etc. Whereas in the application, we have seen modeling and control, which are the 2 predominant title where people approach AI technique. That also we have seen. Then we come to power system. In fact, the power system is full of power electronics. In the presence of power electronics, stability of the system is a big question mark, because these power electronics isolate the total inertial component present with the source, so that stability is a big question mark. So though we have some amount of in resources, we are not in the position to tap maximum due to the poor stability. So we have made a research attempts at NIT Calicut with the help of a virtual synchronous machine, and we have successfully developed a concept, and we have improved the performance of the conventional virtual synchronous machine by proposing novel ideas, and successfully we have done the hardware in a OpenRT. So due to time, I could not convey most of the technical matters, and please look into some of our publications so that you can get all the technical detail. Anytime you can send a mail to me so that we can have enough discussion later. Finally, I have shown a case study of locating charging station optimally in the given distribution system using particle swarm optimization. So with that, I concluded my lecture. So thank you one and all.
Thank you, sir. Thank you, sir. Any queries from the participants?
Sir, there is a question in chat box.
Yeah, I will see the chat box. Yeah. Yeah, yes, correct. So I think Mr. Guru Raj asked the question, how to tune PI controllers for transient studies, such as fault write-through using AI. So here, in fact, the modeling of the system is crucial. Either you go to conventional Sigar-Nicholas method or any AI technique, mathematical model really plays a major role. If you have AI model, in fact, you can take, there is no harm in that. If you do not have a model of the system, you are in the position to create model of the system. So if it is a single input, single output system, we approach Laplace transform. So that we find the transfer function y of s by x of s, which is with full of zeros and poles. So with the help of this, you can infer what is the natural response. So most of the time, when you see our scholars, what they do, they design the value of kp ki trial and error. That is in fact absolutely wrong method. You are not supposed to tune the controllers of PI manually. That is not an engineer language. So what you have to do, you have to develop a proper mathematical system using, in fact, if you have a single input, single output, you can go ahead with a Laplace approach. If you have a multiple input, multiple output, multiple input, multiple output, you can go for the state space approach. So in fact, here also, after a state space, either you can go for eigenvalue and other related analysis. If you are particularly interested in some other response, you can go ahead with the reduction of state space into small signal to the transfer function. So whatever you are using PI control, model is playing a crucial role, because if you want to tune the value of Ki and Kp, you should know what is a natural response. In fact, if you draw Bode plot, you should know what is the phase margin and the gain margin. What is the phase margin and the gain margin? So you have to do enough analysis on the natural response of the system, how the natural system, how the system behaves. In fact, most of the system in our electrical engineering are stable system. I do not know how many of you may agree with me. Stable system are sometimes marginally stable, right? Marginally stable. So most of the electrical system are stable or marginally stable. So then you may ask, why do you want a controller then? No need of a controller. I'm telling you, more than 80% of the system in industry, they are running without controller, right? Open loop system itself is more than sufficient. Why do you want a complex and the difficult closed loop system, right? Unless otherwise, if you want to achieve certain parameter, then you can go for a closed loop system. Because most of the system in electrical are perfectly stable or marginally stable. So marginally stable system sometimes may lead to unstable region due to some disturbance or something else. So that you can easily infer with the help of a Nyquist criterion or some other mathematical tool. You can infer what about the stability region, right? A stability region you can infer. So most of the time, what I know, you can go ahead with the open loop system, because most of the system in electrical engineering are stable or marginally stable. So unless otherwise, if you have certain task such that, sir, my peak overshoot should not be plus or minus 2%. So your natural system will not give this. That's what I told you here. You have to do enough analysis on the natural system. Suppose if your natural system itself gives less than 2%, then what is the necessity of the controller? No need. You can go ahead with the open loop system. Yes. Suppose if your natural system gives some step response, suppose if you do the step response of current, something like this. So this is your steady state value and this is your transient. Here this is your overshoot. Assume that this current is 2 ampere, whereas this current is approximately 10 ampere. So if you permit this, definitely the whole system will be spoiled. So now you may design a controller with a target that your percentage overshoot should be less than 2%. So then you can go for tuning of PI. You may get my point, right? So first of all, you should ensure whether the controller is necessity in your work or not. So if it is required, in what cost? What is your percentage MP? What is your raise time? What is your steady state error? Each and everything you are supposed to know. And then better you approach conventional mathematical methods. If your Sigar-Nicholas method gives satisfied performance, be happy with that. Suppose assume that Sigar-Nicholas method also failed, then you go to AI. AI several techniques like genetic algorithm, particle sum optimization, bacterial foraging, like that several methods. Each method has its own merits and demerits. Then you approach the method one by one and try to tune the parameters of KP, KI using some advanced AI techniques. Then you can succeed with your application. Right? I think some extent I have answered. I do not know whether the question asked by Guru Raj satisfied or not. Yeah.
Thank you, sir.
Yeah. Thank you, Guru Raj. I think he said he is satisfied. Thank you. Yeah. So, is there any other question?